Welcome, this is Richard Jesse, and I'll be presenting an overview of Scorpion, ION's vector size compatible cable land acquisition system. Using ION's decades of experience, Scorpion was designed to withstand the challenges of seismic operations. The system supports traditional geophone strings and vector size digital 3-component receivers. Scorpion's channel capacity in most cases exceeds current seismic acquisition needs for high density and wide offset recording. The system's intuitive user interface and operational flexibility guarantee smooth operations, while extensive troubleshooting features and support for advanced fiber size techniques enable exceptional productivity. The Scorpion ground equipment has been used since 2003 in all regions of the globe. The equipment has been exposed to the brutal cold of the Siberian tundra, has been deployed in the frozen muskets of West Canada, and was used in the extreme heat of the Middle East. Ground electronics components are housed in a metal case to resist damage in transportation and handling, and for better performance in high static environments. Over the years, feedback from our customers has been incorporated in product enhancements. For example, we improved our lightning protection based on customer feedback. Scorpion's architecture enables surveys that call for both 3-component vector size and traditional geophone receivers on the same survey or even in the same active template. The majority of the system components, BVUs, crossline units, cables, and the central system, can be used with either receiver type. Only the inline acquisition equipment, A units and D units, are specific to receiver type. Using vector size receivers, Scorpion users have reported a 15% improvement in productivity compared to geophone operations. Over the years, the size of the active template has been steadily increasing. Recently, the need to produce better data in difficult-to-image areas has been pushing towards increased receiver density and wider offsets. Point receivers also require the receiver spacing to be reduced, which has a significant impact on density and thus channel requirements, as demonstrated by this hypothetical scenario. A 3200 meter offset chute with a typical 400 meter line and 50 meter receiver spacing with one component phones requires support for 2193 channels real time. By reducing the distance between lines to half, 200 meters, the capacity requirement nearly doubles to 4,257 channels. When 3-component point receivers are used, the density often needs to be further increased. With 25 meter station spacing, the total real-time channel requirement jumps to 25,443. The Scorpion ground telemetry is capable of delivering data from 30,000 channels to the central system without any type of compression. This data set is then processed and output to tape or disk before the acquisition of the next record is finished. There is support for up to 4 transverse lines, each with capable of bringing in 7,500 uncompressed channels real time. Scorpion also supports lossless compression, which further improves channel capacity. Microsoft Windows, being the most widely used operating system in the world, was selected as the platform for the Scorpion user interface to reduce training time and ease adoption. Most of the daily spread management functions, such as powering the spread, running tests, selecting templates, and checking spread health, can be executed through the spatially correct map or from one of the schematic views. Various lists allow filtering and sorting of test results or equipment health indicators for troubleshooting purposes. The source-aware feature of Scorpion helps ensure quality data. It checks whether user-configured conditions are satisfied before the data acquisition begins. These conditions usually include the minimum percentage of live channels in the patch and the minimum set of tests that had to be executed on the equipment before the shut can take place. Seismic acquisition systems are used in all kinds of environments, and it is important to provide features to help contractors deal with obstacles and to maximize uptime during expected disturbances, such as line breaks. Scorpion has a number of facilities that aid obstacle avoidance. 3 crossline ports on the XIUs allow the transverse line to fork, which is useful when there are access problems or there is a need for data path redundancy. Line snakes help avoid inline obstacles, and skip gaps are used to go around inline obstructions such as fences or ponds. The data bridge can connect lines without cables. It is commonly used to cross rivers, roads, or runways, and it can support up to 1,000 channels over 1 kilometer. Battery booster units propagate bidirectional power. If a line acquisition unit does not receive power from one side due to a cable break, it can still continue uninterrupted operation on the power from the BBU on the other side. This example shows what happens when a line break occurs and there is a redundant data path laid out, in this case a line snake. The A unit in the circle normally sends data to the primary data path to the central system. If a line break occurs, the primary data path becomes unavailable. So the unit switches over to transmit data downline via the line snake and through the data bridge. Scorpion has recently been improved with new troubleshooting features. The troubleshooting mode is a new operational state of the spread. In this mode, the observer can quickly power the spread up and down as he is finding and swapping faulty cables, batteries, or boxes without the overhead of programming the spread for recording. Once troubleshooting finished, the system sets up the ground electronics and acquisition can begin. An exhaustive line test can be used to find cables that are not broken but perform below optimal level. This test can be executed on lines or the whole spread. The voltage monitoring feature of Scorpion pinpoints faulty equipment by continuously comparing voltage levels reported by the line units to an expected value. When a significant difference is detected, the system alerts the user about this condition and the location of it. The handheld troubleshooting tester can be used in the staging area to find marginal or broken cables, and it also allows the line crew to check the health of cables being laid out without having to bother the observer. Bad cables can be pulled off before the problem would show up on the screen in the recording truck. The new fiber-sized acquisition techniques have been getting a lot of attention lately. Even slip sweep, which is a standard requirement on tenders issued in the Middle East, has been pushed to new limits. In Egypt, 9 fleets were sweeping simultaneously with a 5-second slip time and a long record length. At the end of 2008, distance-separated simultaneous sweeping yielded 12,200 records in one day. That record has since been shattered by an independent simultaneous sweeping production in Libya. There is no doubt that in the Middle East and North Africa, the largest region by install days, the support for these techniques are going to become a standard expectation. These new fiber-sized techniques are regularly combined with source-driven acquisition. In this example, the Scorpion user interface is shown as it manages 3 interleaving fleets. In the past, the support for slip sweep was rather rigid in the system. The operator had to set the slip time, and the crew was responsible for making sure that the vibrator reached the source point location in time. Today, Scorpion is more flexible. Only the minimum slip time needs to be specified, and whenever the vibrator is ready, beyond that time, the central system will start the sweep. The Scorpion user interface on this slide shows that there are 3 source points being acquired simultaneously. The active patches of these source points are automatically combined into a superspread, which is checked by source aware at the beginning of the salvo. The progress of the active source points can be followed in the shot manager. Once a record is completed from one of these source points, the central system creates an output file that only includes the receivers from the active template, not from the whole superspread. With Scorpion, distance-separated fleets do not have to be studied at the same time. This reduces wait time if the vibrators are moving at different speeds. ION's ISS implementation will take advantage of the tight integration between Scorpion and the Pelton source controller. The solution will include continuous quality control of vibrators and the tracking of vibrators. This will help seismic crews reduce the number of missed or wasted source points that had been reported with previous ISS operations. I hope you enjoyed learning about ION's high channel count vector size capable cable acquisition system, Scorpion. Please don't hesitate to call for more information or to request a system demo. For detailed specifications, please visit our website at www.iongeo.com.